So let's get into the calculation now. This is the Haas and Williams formula. It's on your formula sheet right here. I'm going to take a look at it on the PowerPoint right here, and this is just so that it's a little bit larger. So here's the formula. Basically, it is 10.44 times L, and L is the length of your pipe in feet, times Q, which is the flow rate of water in gallons per minute. And this will be something that'll be given to you by your instructor. That's going to be divided by C, which is a Haas-Williams constant. Now that constant is on our formula sheet. It's on this page right here, Haas-Williams constants. And this number is going to come from this column right here at the end, the typical design value. It can have a range, the pipes can have a range like cast iron and wrought iron pipe here can have a range between 80 and 150 for the constant. Clean new pipe is going to be 130. So what they do is they just decide on a typical design value. In this instance, for cast iron and wrought iron, it's going to be 100. You can also have copper or glass or brass piping. You can have cement line pipes and all these different kinds of pipes. And they all have different, or well, these two are the same. But anyways, this is where the C comes from in this formula. And then that is times the diameter of the pipe raised to the 4.8655 power. So back to our formula sheet again, just to show you that. Here we are. Remember, we don't bother with the screwed fittings. We're just only worried about flange fittings. And right here across the top is 10. So all the values for elbows and T's and return bends and valves are going to come from this column right here.